Hi everyone. Yeah. So let's talk about the second challenge, which is revolutionizing retail with AI enhanced stock management. Now, before I start talking about the challenge, I want to walk you through a story. So that's me, let's assume. And I recently bought a new house, and I wanted to put all the best things in the house, the best curtains, the best sofas, the best everything. So on the internet, I found this vase. For me, I fell in love with this vase immediately, and I wanted to have it. So like everybody else in the room, I placed the order. Believe it or not, that's how long I waited, even for my order. So, it felt like forever. And after 2 weeks, they canceled my order, right? And obviously, I'm sure most of you have faced this issue at some point in your life. I went through a lot of emotions, but the first thing that I did, I went to another company and I placed an order for a different vase. And what was that? That was loss of business for them. But also, once I got my vase, I told my friends, if you order from this company, they might do the same to you. And that was loss of brand image. In the retail sector, these are the most crucial things. So I tried to put myself in the place of this business to understand what could they have done differently. Well, my first idea was maybe they could have bought 1 million products and never go out of stock. But obviously, they couldn't have done that, right? So that was out of the window. What else could they have done? Well, they could have tried to estimate accurately how many products do they need to buy to satisfy customer demand. And that was the first half of our problem, demand forecasting. We leverage machine learning, deep learning, transformers to get to the accurate and the precise number of products that we need to order. But that's not enough. Once we know that we need to order a X number of amount, we also need to take into account multiple different factors, like the time for restocking, the current inventory, the discounts, shipping costs, etc. And that was the second part of our problem. To answer the question, when should I buy these products? Now, this was done using inventory optimization. We optimize for the current stock, for shipping costs, for discounts, and multiple other constraints. Now, let's understand the scope of our problem. We were dealing with almost 309 different products. Now, a domain expert can look at a product and say, okay, maybe you need to buy 5 products in the next week. But imagine doing that for 300 different products at scale, simultaneously and accurately. We also had data for over 2 years, and we had to make weekly as well as daily forecasts. Now, we leverage, for the demand forecasting problem, we leverage 3 different types of models. We looked at statistical models, machine learning models, deep learning models, to try and approach this problem holistically. Now, I don't have to tell the people in this room, Rome wasn't built in a day, and neither was our project. We started from week 1 till week 6 with an average error of almost 15. What does that mean? If we forecast 100 as the demand for the product, the actual value could be 115, maybe 85. But by the end of the sprint, we were able to get down to almost 2 in error, which means if we tell you that you need to buy 100 products, the real demand would be 100 or 2 or 98. And in the last 2 weeks, we spent time fine-tuning our models for doing the integration testing and creating our APIs. Let's look at an example for how this product works. So let's say our model tells you that you need to buy 310 products. That is already pretty accurate, like we showed you. But could we improve this a little bit? If you bought 310 products, on the cost curve, you would be paying, let's say, 9,300 euros. This is an actual example that I'm talking about. You'd be paying 9,300 euros based on the average buy price. But this is not it, right? You have multiple different constraints. Maybe you get discounts for buying a lot of products at the same time. Maybe you have some costs associated with the shipping. Once we account for all of that, we can actually put this information in our optimization module and get a graph that looks something like this. What does this mean? By buying 20 more products, you actually save costs because there might be some discount programs. That is saving of almost 25% by making a simple data-driven change in your buying activity. And instead of buying 310, now you buy 330 products. So let's do a deep dive into how the whole pipeline works. We start by taking the historical sales data and run it through an algorithm selector, which is just a bunch of statistical rules to decide what model would work best for your products. It could be an LSTM, an ARIMA, a moving average, etc. These models then predict the demand over a period of time, which we call the forecasting horizon. Once that is done, we also take external constraints like current stock, shipping costs, manufacturing discounts. We bring it all together in the inventory optimization module and then tell you the final buying decisions that you need to run. Now, why should you care, right? Well, this was our solution, but it can become your solution as well. The framework that we have created works holistically with any sort of problem. We take your data, run it through our framework, we take your constraints, put it in the inventory optimization, and we tell you how much you need to buy. This solution, it's generalizable for any industry, but it is customizable for your problems, and it is reliable because of the results that we just showed you. Now, the retail sector that we can possibly target, the $860 billion clothing industry, the 1,600 billion pharmaceutical industry, and the 200 billion food delivery industry. These are just some examples in the retail sector which could leverage technologies like these to drive more data-driven decisions and make better buying outcomes. Of course, with great work can only be done with a great team. Hari, the deep learning researcher, Valerio, our statistical expert, myself as the machine learning engineer, and our mentor, Adrian, made this possible. Thank you so much.
Hello, everybody. Thank you, Prakhar. So my name is Marcello Politi, and I'm one of the machine learning scientists of PySchool. And for the last 8 weeks, I coached this challenge. So I would like to spend some words on the team. I think that we were able to create this great framework because of the synergy inside the team. We had experts in different fields, so from statistics, software engineering, and deep learning, and it is why we were able to face all the issues or the challenges of the project. I really think that the product we developed is valuable because I would say that, as Prakhar explained, is domain agnostic. So you can just change the input and use the same pipeline for different domains, different topics. But what I think has a great value and that the team learned during these 8 weeks was how to translate complex business requirements into technical ones. So working step by step on technicalities while translating, the requirements from the sponsor that sometimes are really hard to understand.